it's very tedious in some cases or many cases. Whereas if we approximate it using the central theorem,
Mhm.
and it is much easier and very close.
Very close to whatever. Suppose we want to estimate the mean and all.
Correct. Unless
Sir,
instead of the other things that we have seen, lower bound, upper bound,
Mhm.
they vary quite a bit from the actual. Whereas this is actually very close and much easier.
Correct. Anybody
sir,
else? Yeah,
Sir,
go
sir,
ahead.
if we have n sampling if we have n sampling instances x1, x2, xn
Mhm.
with mu n sigma square with unknown distribution,
Mhm.
then we define a random variable which is a function of these sampling instances. Then we convert this function to a new random variable which follows normal distribution when n reaches to infinity. Number of instances reaches to
Basically,
infinity.
when your sample size will be large. So thing is,
Yes, sir.
you can think like this. Suppose you are going to do any, you are in real life scenario, okay, and you have collected the data. So, but it's possible, right? That data may not be from normal distribution. I mean, that may not satisfy the criteria of normal distribution, right? Suppose you want to collect the data of, let's say, that have binomial kind of nature, only S, no, pass, fail, something like that. But at the end, whenever you have been large sample size, right, then your mean will converge to the population mean as per the central limit theorem. Okay, so basically, yeah. So till now, whatever you everyone told, that's correct. Okay, so let me start. Before going to the slides of peer day, let me show you something to all of you. Can you see my this screen? This R console is visible to all of you.
Yes, sir.
Yes,
Okay.
sir.
Do not
Yes.
worry. These codes and all are not going to come to your in exam. This I have written here just to give you idea about central limit theorem. So do not worry about this, codes and all if you are not familiar with R. So this set dot set is just for reproducibility and all. Okay. So do not worry. I'm just going to show you the idea behind central limit theorem. So thing is our original is it's lambda I have introduced as a 1. Okay. Basically I'm going to take from sorry, not norm, exponential distribution. Okay. So you can see I have generated some samples, 1 lakh samples from exponential distribution. Okay. Is this line clear? You can see this is
Yes, sir.
non-normal distribution. We will try to see whether it's going to converge to normal or not. Okay. So this is the graph of your exponential distribution. All right. So far so good.
Yes, sir.
Okay.
Okay.
Now, so this is, I mean, this is just you can say it's a density curve. Now let's try to do the our CLT, try to verify the CLT part. Okay. So you can see for different sample sizes. So here I have collected for sample size 5, 30, and 50. So you can see what is the mean of original distribution? What is the mean? Mean is lambda, right? In case of
Yes, sir.
exponential, sorry, not lambda, 1 by lambda, right?
Yes,
And
sir.
anyway, it is going to be 1, correct? Yes or
Yes,
no?
sir.
See, mean of exponential distribution is what? 1 by lambda, right? If lambda is 1,
Yes.
so 1 by lambda again is 1, right? So you can see when here sample size was 5, sample size was 30, sample size was 50. So as sample size increasing, you can say curve you are getting as a normal, approximately normal, and you can see mean is, you can see the red curve, right? Mean is approximately 1, right? It is converging to 1. Here it's
Yes.
close to 1, not exact 1. Are you getting my point?
Yes, sir.
Everyone is getting the application of CLT, right? You can see whenever we are increasing sample size, it is going to converge to the mean of original distribution. Basically, it will approximate the normal distribution. Is it clear?
Yes, sir.
Okay.
So how it is going to help in real life? Like we
Okay. So suppose you are collecting data which is not following the normal property, right? Let's say some binomial property is there. Okay, and let's say then you have large data, but if you're discrete kind of thing, then it typically if you're going to calculate, if you're going to formulate, if you're interested to find any probability and all right, so it will be very difficult to compute everything, right? Or else to do the integration and all. Yes or no? Right? So if this by this central limit theorem, you can approximate the normal distribution. Then by using the normal distribution, if you have normal distribution, you can simply convert in standard normal, and then you can find the table of you can find the values from standard normal table. Okay. So let me increase sample size. Let's say 500 also. Let's try to see whether it is. Then you can
Sir,
find.
one more doubt.
Yeah.
Yeah, actually, can you just show these three graphs? Can you make them a little bigger?
One second. Let me. I increase one more sample size. Let me show you the FAB for 4. Okay. Now. Yes.
Yeah. So actually, if I see the sample size is 5, 30, 50, and 500.
Correct.
Whereas I see the number of bars in the bar diagram very same and similar between 5 and 500 also. I mean,
Yes, so those, okay, once again, that green bars basically, okay, show you. So that it depends on the number of sample size, right? So, okay, do not worry. Okay, one more thing. How many samples we are generating? That's why I told you do not go with the code. Here we are generating 1 lakh values from exponential distribution, right?
okay.
Yes, sir.
Okay. Are you getting my point? So here we are generating 1 lakh, and here we are, you can see we are generating 1 lakh values, and we are taking the basically it's a sample mean we are taking. You can say this x-axis is about sample mean, okay, and y-axis is repeating how many times it's repeating, right? How it will generate 1 lakh values. If you, I will type the population. Let me show you. You can see. So see. It's not showing all the entries, but it's 1 lakh with repeated values, right? Then you will take mean and all, then you will do the same thing for different type of sample size, okay? If you are interested, I can share with you code and you can play with that. The key idea I want to show you, whenever you will increase the sample size, right? It is going to converge to normal distribution. As you can see for 500, okay? If you increase, you can see, okay, so you can see the mean is basically at 1, right? Peak is at 1 in normal. You can find the symmetrical. Yes or no?
Yeah.
Okay, if you are interested, I can share with this code.
Is this in Python?
No, this is R software.
Okay.
One more code I have written. Maybe, let me show you. I don't know.
Sir, this POP lambda less than -1, can we assume any value for that?
No. Okay. What is the property of exponential distribution? Lambda should be -1 or lambda should be greater than 0? So one more thing you can try. Let me show you something. Yes, it's a kind of animation I did. So you can see as we are increasing the sample size, right? You can see on the above it's a 20, 30. It is going increasing, right? 50, then 100, okay, then 1000. So you can see its peak is at the peak is going to converge to the mean, right? Original mean. Original mean was 1 only, correct? And while the sample mean is from what are the values you are going to generate. So here you are asking lambda is -1. So no. So it's the exponential distribution, right? It can't take as per the exponential property negative values. What you can do, if you are interested here, you can generate the from uniform distribution, okay? And accordingly here parameters will get changed. Let's say you are going to generate the uniform distribution. If I will run this code.
Isn't this a bit greater than 0, sir?
Which one?
This lambda should be greater than 0.
Once again, I need to check the what is the command of R unit. Yeah, so basic thing is let me check. R unit is unused. Okay, I need to check this arguments actually. Yeah, so thing is here initially it was exponential, right? Similarly, you can change uniform, R binom, whatever you can use. So if you are okay with Python or anything else, so you can try on your own. Basically, the key thing is you can see whenever I'm going to increase the sample size, it is going to convert to the normal. If you are okay with it, if you are familiar with this R, then you can try this code on your own. Okay. So, okay, you got that like idea, right? How it is going to convert? I mean, what is the idea behind it? Yes or no?
Yes, sir.
So it's not something we are talking about randomly. Okay, let me present the this peer day code. Please join it fast so that we can start the session. And we'll in the beginning of the session, I heard all of you. I mean, most of you are not able to solve the question. So we'll try to finish the questions from the slides, and then we'll try to solve some activity question, right? Questions related to central limit theorem. Okay, maybe that will give you idea how to approach the questions of central limit. So all of you are aware about this, right? How to join this PDA? You have to basically enter right on a browser joinpda.com, and then you have to enter this code YIFZON. Okay, you got the idea, right? Why these are bars and all? This green part, red part.
Yes, sir.
Okay. Yeah, so this is the code. Yeah, 8 of you have joined. Rest of the people, please join it so that no, we'll try to solve more questions related to central limit theorem. So whenever you are finding the questions related to central limit theorem, right? Very first approach is to first of all try to convert it. Try to find out the first of all distribution of let's say suppose y is given as summation of xi or summation of xi by n. Then first try to find the mean and variance, and if sample size is large, simply convert into the normal. Now once you have converted into normal variate, then if you know this is the normal, then what you can do next step? Next step will be you can convert as a standard normal distribution, right? And once you converted in standard normal distribution, then you can find the values from Z table. Okay, 16 of you have joined. Yeah, Vimlesh, I will come to that. Okay, the activity 8.2 question number. Question number. Okay, so you are asking about all questions. You didn't try or you? Okay, okay. Come, I will come to that point. Okay, activity 8.2. Do not worry. We will see all those questions. Activity 8.2. Okay, it's a central limit theorem only. Okay, do not worry. First, we will try to solve the questions and then we'll come up with the. Yeah. All right. No, not a problem. Okay, others, please join it fast so that we can start the sessions already. Sorry, 6:21.
Sir, one question. So for this quiz 2, the syllabus will be from week 5 to 8, or there will be
1 to
some.
8, 1 to 8, 1 to 8.
Okay.
Major portion will be from 5 to 8, but it will cover content will be from 1 to 8.
Like 50-60%. Can you give some idea?
I'm not sure right now, but I will share the week wise weightage in few days.
Okay.
Maybe on Discord or through mail, we'll share the week wise weightage, like what is the week weightage from week 1 to 4 and 5. And
Okay.
you can approximately start your practice.
Okay.
When is the quiz to? 1st December, if I'm not.
1st
Right?
December.
Yeah.
Yes, sir.
Okay, please. I think there are around 38 class. Rest, you don't want to join this, or you are joining? Please join it fast. It is what if you are facing any difficulty, do let me.
Sir, the link is not opening.
Which link?
Yes, sir. joinpd.com.
I think just simply enter joinpd.com on your browser. Right? Then it will ask enter a code. Then you can enter this code, top right corner code you can see on my screen. YIFZON.
Are you getting an error, or you're having?
Mhm. 22. Okay, so others please join it fast, and do let me know if you are facing any difficulty. So code is this top right corner, you can see on my screen, this YIFZON. So very first question is, question 1 is saying, let x1, x2, x100 be independent, identically distributed random variables, each with expected value mu as a expectation of xi 3 and variance as a variance of xi 9. So to approximate the probability summation of xi, I mean x1 x plus x2 plus x100 greater than 100 using the central limit theorem. So here you have to basically enter your answer in terms of fz. No need to give the final answer. So something we have seen in week 7, let me give you idea. So in week 7, we have seen already if x1, x2, xn, this is IID from x, and each xi, basically what is the mu, and variance of xi is sigma square. So we have seen what is the, let's say I'm saying s as a x1 plus x2 plus so on plus x of n. Then what will be the expectation of s?
And mu.
And mu, right? Basically, it's x1 plus x2 plus so on xn, right? And we know, and I can write this as expectation of x1 plus expectation of x2 plus so on expectation of x of n. So mean of each xi is mu, 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 and so on mu. So this is n mu.
Yes.
All right. And what is the variance of s? Since all are IID, I can write variance of x1 plus variance of x2 plus so on variance of xn. Correct?
Yes,
So
sir.
variance will be terms will be 0. So it will be sigma square and so on sigma square, right? N times. So it will be n sigma square.
And sigma square.
So what is the
Yes.
distribution of s here? It will be normal. Since sample size is large, then I will say s will follow normal. What is the mean of this s? Is n mu
And mu.
and variance n sigma square. All right.
Yes.
Now,
Yes,
what is
sir.
the, whenever you have been given the question related to central limit theorem, so this is, this S is normal distribution. So to calculate any probability, what you will do, you have to convert into standard normal variable, right? So what is the standard normal variable? How you can convert? So if I have to convert a random variable into standard normal variable, then what I have to do? Random variable minus expectation of random variable divided by standard deviation of random variable. This will follow normal 0, comma. Yes or no?
Wow.
So this is nothing but this will become your z, right? And then if exact value is given to you, then you can go with you can calculate the basic probability. Fine.
Yes, sir.
Yes.
Okay. So this is the question. Let me give you 3 minutes and do let me know if you need extra time. Okay. Now apply the concept.
Do we have options for this question?
No, not option. You can read the question. It's you have to write in terms of object. Okay. Do you need extra time limit?
So just probably another minute, sir.
Oh. Do you need extra time limit? Anybody?
No, sir.
I received only 8 responses. So.
Sir, just completed and it is already logged, so I have put my answer in the chat box.
Okay.
No problem.
Oh, got it. What about others? Do you need extra time limits? Okay, feel free to ask extra time limits, not something. So.
No, sir. Solved.
No, I'm saying for others because I received only 8 responses. So that's right. So even if you don't want to try, you can let me know. I can share the PDF itself, right? So there is no point of waiting here. I can simply discuss the question. So this time and all we are giving just to give an idea. I mean, you will gain some confidence. Yeah, you are able to solve this kind of questions in the given time limit, let's say 2 or 3 minutes, whatever. It's a request to everyone. Try to solve. If you need extra time limit, feel free to ask. Just for you are watching the lecture, so simply I can share this PDF or else I can no, read the question and I can solve the questions on my own. Okay, anyway, so that's a request to everyone. Please try to solve more than. Okay. So let me see the responses. So FZ 32.33. Okay, someone has entered X minus 300 over 900. F1 minus FZ minus 20 by 3. Yeah. Okay. Okay. All right. So here we
The
have.
answer is 0.004, sir.
Okay. 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 Let's see. Yeah.
Yeah.
So here we have 100 IID random variables, right? So if you have 100 IID random variables, and we have seen by using this information, okay, by using this information, so instead of n, we have 100, right? Correct.
Yes, sir.
So what will be your S? Okay, let me write. So what is the X? It is given as x1, x2, x100, right? This is all our IID with X, where each Xi is how much? 3, and sigma square, which is variance of each Xi, is 9. All right. So I told you what is the very first thing. Just try to write S or Y, anything, whatever. So question is we have to find the sum of these 100 IID random variables, and by using the central limit theorem, okay. So what it will be? It will follow normal of with mean what? Mean is
Mean is 3.
3, right? 3 or 100 into 3, 300, right?
300, 900.
See, if you see, it's a x1 plus x2 plus x100 only. So what is the mean? It is going to be n mu, right?
Oh.
Okay. If you are not able to recall, just simply solve at. It will take less than minute. So what is expectation of x? Expectation of x1 plus x2 plus so on x100, right? And now I can write irrespective of the independence in case of expectation. So what is the mean of expectation of each x? Is the 3, right? 3 plus 3 plus 3. So it's a 3 into 100. So it will be 300. Same in case of variance. If you want to find the variance of S, so it will be variance of x1 plus x2 plus x100. We know x1, each x is IID. So if it's IID means it's independent. So independence means I can write as a sum of individual variances. And what is the each variance of each xi? It's a 9. So 9 plus 9 plus so on 9. It will be 100 times 9, which is 900. Now we have information, my random variable s, which is x1 plus x2 plus so on x100. This is normal 300 comma 900. So what is the question? Question, you can see we have to find the probability summation of xi is greater than 100. So that means probability x1 plus x2 plus so on x100. This is greater than 100. We have to find this probability. This will be probability s greater than 100. Yes or no? Now we know this is the normal. So what should be your next step? Next step should be I have to convert in standard normal. Then how I can do? S minus expectation of S divided by standard deviation of S. Yes or no? And the same approach things we have to apply on the right side of this inequality. So 100 minus expectation of S divided by standard deviation of S. Is this clear? This step is okay to all of you? Yes? No? Anything?
Yes, sir.
Okay. So what is this?
Yes.
This is now my Z, right? Yes or no? Normally we are denoting G or Z as a standard normal variate. This is greater than, what is the expectation of S? 300.
Yes.
What is the standard deviation? This is variance, so standard deviation will be 30.
Yes, sir.
So now this will be probability Z greater than minus 200 divided by 30. So this will be probability Z greater than minus 20 divided by 3, right? So question was to convert in FZ form in terms of FZ. And we know what is the FZ. This represents the CDF, right? That means probability Z less or equal to small z, right? This you can see this is in terms of greater than sign. Can I write this as a 1 minus probability Z less than or equal to minus 20 by 3? Yes or no?
Yes, sir.
So
Yes,
I can
sir.
write this term as a Fz of minus 20 divided by 3. So this is the answer in terms of Fz. Is this clear? So the key thing you have to do, you have to find this as per the CLT, you have to find the mean and variance, and you know by the central limit theorem, it will be approximately normal. Since you know this is the normal, the next step should be you have to convert into standard normal and then find the. All right. Any doubt?
Uh,
So you can
yes,
see
sir.
here the
Sir, I
same
was
calculus. Yeah.
and actually I was thinking that mean and sigma
Hmm.
of x is what we have to use how I understood so far. But we have found the mu and sigma of the y.
Correct.
Oh, is it?
Yeah,
Okay.
that's what. See, I think you got confused with the. Okay, let me show you something. Suppose instead of this x1, x2, xn as 100, right? Sorry, summation of each xi. Let's say I'm saying s is defined as, let's say, x1 plus x2 plus so on xn divided by n. That's it, basically mean, right? So
Correct.
you can see, suppose x1, x2, xn. I'm saying this all are IID with x. So what is the meaning of IID? It's the identical, right?
Correct.
So
Correct.
identical and independent. So identical means mean and all everything should be same for each xi,
Correct.
correct? So
Correct.
if I want to find what is the expectation of s, so I can write this as 1 upon n expectation of x1. I think this is something we have done in week 7
Correct.
already.
Correct.
So what is the numerator part? Mu
N,
plus mu plus mu n mu
N mu.
divided by n. It is mu,
New. Correct.
right? And in the previous question, only this part was there, right? Now,
Uh,
if you find the variance of s, so this will become variance of 1 by n, I mean x1 plus x2 plus so on xn, right? So it will be n square, 1 upon n square outside, because variance of a times x is nothing but a square variance of x. Since each x is IID, then I can write as the variance of, I mean, sum of the each individual variances, right? The
yeah.
numerator part will be sigma square plus sigma square, n sigma square,
Yeah. By
n square.
n square. So sigma square by n.
So this is true when my s is x bar, and it will be normal mu comma sigma square by n. Okay. And
Uh,
while initial my s was summation of I is equal to 1 to n, this will follow normal n mu comma n sigma square. Okay. So do not get it confused this part. Okay. Now it's clear.
yeah. Yeah.
Yes.
So the next question is x1, x2, xn, x100 are IID normal 0, comma 2. Make sure here it's already given your xi's are IID normal 0, comma 2. You have to evaluate the probability that x1 square plus so on plus x100 square greater than 220 approximately, and so exact value is given to you. Okay. So what you have to do? First, try to find the mean and variance of this part, right? X1 square plus 1 x100 square. And since you can, once you will find the mean and variance of this part by using the central limit theorem, this quantity will go for the normal with some mean and some variance. And then you can apply the central limit theorem. Yeah, then you can convert into the standard normal variable, and then you can go with. Okay. So I'm going to give you 3 minutes, and please do let me know if you need extra time. One small hint here, if you don't know, so if xi follows normal distribution, then xi square will follow gamma
Gamma.
distribution. Okay, and then similarly you can do the addition of gamma. Anyone? Extra time limit?
Yes, sir.
1 minute or
Calculation taking time.
3 minutes?
2 minutes. Yes, sir. Yes.
Okay. Okay. Anyone, do you need extra time limit or should we proceed with
You can discuss the answer, sir.
some answers? So someone 1, 2, 3, 8, 5, 1, 2, 4. Okay. Majority is 1, 2, 3, 8, 5. Let's see. So okay, it's given that x1, x2, x100 is IID normal 0, comma 2, right? So question 2 says x1, x2 till x100. This is IID normal 0, comma 2. So it's IID normal 0, comma 2. What is the expectation of each xi is there? 0, and variance of each xi
Expectation
is
is
2, right?
2.
Here only. And
Yes.
question is you have to evaluate x1 square plus x2 square and so on. Probability that this x1 square plus x2 square plus so on plus x100 square is greater than 220. So if we are interested to calculate this part, so we are going to use one property. Okay. So property, I mean, it's a one concept maybe you can recall from the week 8. So if x1, x2, and so on, xn, this is IID normal, means IID normally distribution with mean 0 and variance sigma square. Okay. The concept is then each xi square will follow gamma with parameter half and divide by and comma 1 upon 2 sigma square. Okay, and all xi's will be independent. Okay, and sum of this actually one another concept is sum of n independent gamma alpha comma beta. I mean, these are two parameters, alpha and beta is two parameters. So if you want to, if you sum of n independence gamma alpha comma beta, so this will give you, this will be basically gamma n alpha comma beta. We are not going into the derivation part and all. Okay, if you are interested in derivation, where from where this is coming and all, then we can discuss on this course and all. I mean, we can solve this thing. So basically, from here, what will be the case x1 square plus x2 square plus xn square will give you what? It will be gamma. So what should I write? By using this information, what is the alpha here? Half, right? It will be n by 2, n alpha, yes or no? And beta is the same, right? That is, what is the beta parameter? 1 upon 2 sigma square. All right? Any doubt here?
No, sir. All clear.
Clear? Right. Now, so here in the question, you have been given x1, x2, x100. This is IID normal 0, comma 2, right? And we have been given then xi square will follow what? Gamma, what is, it will be half 1 upon 2 sigma square, right? So it will be
Yes, sir.
1 upon 2. What is the sigma square? 2, right? So 1 upon 2 into 2. So this will be gamma 1 by 2, comma 1 by 4,
Yes, sir.
right? Now, if I want to write x1 square plus x2 square plus so on x100 square, then what it will be? So, okay, by using this information, you can simply calculate the expectation of each, I mean, this sums. So, what it will be? 100 by
100
2,
into 1 by 2. 100 into 1
right?
by 2.
Let's say, let me define this as a S. Okay. So, what is the
Yes.
expectation of S? Expectation of x1 square plus x2 square plus so on x100 square, right? Okay, before this,
Yes,
you
sir.
see, by using the information, this will follow gamma, okay, rather than calculating like this. So this will be gamma n by 2, comma 1 by 2 sigma square or not.
Yes, sir.
Everyone is getting this part, right? How I'm writing. So what
Yes,
is
sir.
the n here? It's a
100.
100 by 2, comma 1 by 2 sigma square, which is 1 by 4 only.
1 by 4.
So far, so good. Any doubt here?
No, sir.
No, why sigma square? Why not n sigma square?
Sorry, why not?
The summation will be
Yeah, that's what I'm saying. We are not going into the derivation part. Okay, it's a one of the property we can cross check. Okay, so we are not going to the derivation part. If you want, we can do it later. The key idea is here. Okay, so how you can calculate this and all things. So maybe you heard about moment generative function. You can find the MGF of this. Okay, and then if you
Yes.
calculate the MGF of this, these both will be the same. Okay, so this is proved part. Okay, it's not like we are talking randomly. As of now, we are not doing the derivation. Okay, we are just keeping in mind the property. Okay, it's not we are talking about in general and sigma square. Okay, so you can see from here it will be basically one more thing I can say you. So this is called shape parameter and this is called the scale parameter. If you go in gamma distribution and all. Okay, so it will be n by 2 1 upon 2 sigma square. Okay, so by using this information, it will be 100 by 2, 1 by 4. Clear? Okay, those who have done, can you tell me how to proceed here? How will you proceed? Yeah, basically.
mean is alpha by beta and variance is alpha by beta square.
So this is 220, right?
Yes, sir.
Okay. So mean, okay, in here, this, this is the gamma, right? This is alpha,
Yes,
this
sir.
is beta. Someone told what is the mean of this is alpha by beta, right? So this is
Yes.
50 comma 50 into 4. Let me write.
Yes.
So
Yes.
expectation
Yes.
of a
50
gamma, I'm writing as a G, it's alpha by beta. So it will be this 100 by 2 is nothing but 50 divided by 1 by 4, which is nothing but
50 into 4, 200.
200, and variance of G alpha by beta square,
Yes.
right? So 50 into 1 by 16.
Yes, sir.
So what it will be? Let me write 50 into 16 as of now. Okay. Now,
8.
using the central limit theorem,
Yes.
let's say this is S, this is greater than 220. Now what I can write? What is the mean of this S? 200.
Yes, sir.
So S, okay, what is the next step? Basically, I have to convert into standard normal variable. So this
Yes.
S minus expectation of S,
Expect.
let's say here I have written as a G, let's say this is G. So G minus expectation of G divided by standard deviation of G greater
Yes, sir.
than 220 minus expectation of G divided by standard deviation of G,
Yes.
right? So this part will become Z
Z.
greater than 220. What is the expectation of Z here?
200.
200, and divided by standard deviation of Z, it will be square root of
Square
this
root
part,
of
it will be
800.
4 square root of 50.
4 root 50. Yes.
So this will become probability Z greater than 20,
28.28.
this part, right? So it will become probability Z greater than 5 divided by square root of 50, right?
Yes, sir.
So 5 is square root of divided by 50. That means what I can write? So 5 divided by, inside the square root, I can write 25 into 2.
Yes, sir.
So 25, it will take, if we take outside the square root, it will
5
become
root 2.
5 divided by 5 root 2. 5 will get cancelled out. So probability Z greater than 1 upon root 2. So what is the value of 1 upon root 2?
0.773 approximately.
773. 7071, right? If I'm not.
Yes, sir. Yes, sir. 7071.
So this will be 0.7071. And since this is greater than sign, then what is to calculate the abject value? What I have to do? I have to convert into less
1
than,
minus.
correct. So I can write this like this, and 1 minus fz of
07.
0.7071, and value of this is given as 0.6
0.76115.
yeah, 0.76115. Then you will subtract it, so it will be 5 8
8.
3 2. Okay, 0 point, this should be the answer. Okay, so everyone got this
Yes.
or this part is confusing?
So I got the answer,
Hmm.
but the summation of xi square following gamma.
Okay, okay, Bimlesh, one more thing. So we are not going to do the derivation. If you are interested, we
No,
can
I'm
do.
not
Okay.
talking about derivation.
Mhm.
I
You are saying why it's not
no,
n
no, no,
beta?
wait. Let me tell you. See, individual xi's are following normal 0 to suppose,
Mhm.
and then xi square is following gamma half 1 by 4, correct?
Mhm.
The summation I took is following gamma n alpha and
Beta.
n beta, and from there I calculated
Hmm.
variance which was 800. What
Okay.
is wrong in that? Or if that is not wrong, is that also acceptable way? See,
Hmm.
alpha is
Hmm.
1 by 2,
Hmm.
beta is 1 by 4. 100 alpha by beta square is anyway 800.
100 by
100 times alpha by beta square is 100 times half by 1 by 16, which is 800.
okay.
So instead of memorizing that sum of xi square and xi square is n alpha comma beta, we can
Mhm.
simply go by sum of individual xi squares, no? And find the variance from there.
See what the
See, what I
Hmm.
did is, I'll tell you, S is equal to x1 square plus x2 square up to x100 square, correct?
Correct. Correct.
Now, each xi square is following gamma half 1 by 4, correct?
Hmm.
Expected value of S is 100 times alpha by beta, which is 100 into half by 1 by 4, which is equal to 200.
Okay. Correct. That's correct.
Variance of S is variance of x1 square plus x2 square up to x100 square, which is 100 times, because the 100 times alpha by beta square, which is equal to 100 times half by 1 by 16, which is equal to 800. This is how I approached.
Okay.
Now, is this correct or
So yeah. So thing is, if you are doing, you are writing, and one more thing. So what you have written, x1 is square plus x2 is square plus xn is square, right? So you have written as a gamma n by n alpha, and you are saying summation of this would be n beta, right?
no, I haven't written like that. I just found out the expected value of this summation, which is
Uh,
expected value of each xi, because these are identicals.
if you take n, that is 100 by 2, 100 by 2 will become 50. Uh, I
You
need
please write s equal to this summation.
one second. Yeah,
You
yeah.
please write s equal to this summation and write es equal to expected value of this summation.
Yeah, yeah, go ahead.
And then that will be n times expected value of xi square.
Yeah,
And
correct.
now that xi square is following gamma half 1 by 4, correct?
Mm-hmm.
Then 100 times alpha by beta gives you 220. This is how I found out the expected value of S.
Okay.
Similarly, for variance of S, I found out variance of x1 square plus x2 square up to x100 square, which is equal to 100 times variance of xi square. Now, variance of xi square is alpha by beta square, which is equal to 8.
Okay, yeah, correct, 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 correct.
So,
I
variance
got,
of
yeah,
S is 800.
correct. I got your point. So what you did actually, that's also correct. So let correct me whether I got it point or not. So what you are saying, xi square is nothing but gamma half comma 1 by 4, right? Correct. That's something you are saying, right? This is
Yes,
given to
yes.
us, right? Now forget about summation of each gamma. Okay. Now if I will forget about each gamma, so what will be the expectation of each? Okay, let's consider each xi square as a yi for simplicity.
Okay, so what you're saying, memorizing the formula of summation of xi square
So okay, that
and help in
okay.
calculation first.
Okay, so if see,
Absolutely. Yeah.
thing is, yeah, I got your point. Thing is, if the property is in your mind that you will do, I mean, it will save your time some in a minute, some right. So
Understood.
if you don't know, then you can go with also. So let me show you how. Okay, I got your point. What you're trying to say. So let's say each xi square I'm going to represent as a yi. That I can do, right? Now, what will be the expectation of yi? Alpha by beta, right? This is alpha, this is beta. So alpha by beta, 1 by 2 divided by 1 by 4, what it will be? 2,
Yes, yes.
right? Now, what is the variance of each yi? Alpha by beta
Alpha by
square,
beta
1
square,
by
which
2,
is
1 by
8.
16, which is 8, right? Now, so thing is, you can see here, what is the yi? Yi is nothing but, it's the, what is the mean of each yi? It's a 2 and variance of yi is 8 and we know all are independent. So what is the next case? So next case is we have to calculate x1 square plus x2 square plus x100 square. That means what we have to do, y1 plus y2 plus y100. Let's say this is your s. All right.
Yes.
Correct? I can write like this. So this is the S, and we have seen by the central limit theorem, what is the mean of this? If you see, this is normal, and we have seen this will follow n mu, comma n sigma square or not. We are not using here the property by gamma. Now you can think this as a refresh. Okay, yi's are independent random variable with mean 2, variance 8. Then you have to calculate the sum of this yi's. Okay, so this will be 100 mu, right? So 100 into 2 and 100 into 8. So this will become normal 200 comma 800, right?
Correct.
Correct. So now we have to calculate probability that x1 is square so on plus x100 square greater than 220, and we have introduced as a s. So this will be s greater than 220, and the same procedure, s minus what is the mean 200 divided by square root of 800 greater than 220 minus 200 divided by square root of 800. So 800 nothing but this is same as like. So you can go with the both approach. If you know the property, that's okay. If you don't know the property, then you can go with this property. But one property you have to keep in mind if you are going with this xi square will follow the gamma with this half and 1 upon 2 sigma square. That is you have to keep in your mind. Okay. All right. Clear, right? Is that the same thing you were saying, Bimles, right?
Yes.
Yeah. Oh, is this clear to all of you? You can see the same
Yes,
answer,
sir.
0.2385. Any doubt?
No, sir.
No, sir.
Okay. So next question is given as x be a random variable having the gamma distribution. So there are parameters alpha as n and beta is given to you as 1. So, and there is a one hint like x follows gamma, then alpha beta, then what is the expectation? Alpha by beta, and variance of x, alpha by beta square. Then by using the law of large number, you have to find the value of n. Okay. So just calculate the value of n. So I'm going to give you 3 minutes, and do let me know if you need extra time. Do you need extra time?
Yes.
1 minute or three?
3 minutes.
Okay, so you are still trying, or should we proceed with the solution part?
Sir, proceed, sir.
Okay, we're not able to calculate.
Yeah, I couldn't.
Okay, no problem. Let's try to see. Okay, so first of all, let's recall what is the weak law of large number. I mean, what weak law of large number says. Actually, okay, what you will get from weak law of large number? Basically,
Upper bound.
upper bound of what? Like, what's the use of weak law of large number? Basically, why we are using?
It is another approximation technique where it gives you the bound. I mean,
So suppose
it
I'm saying I'm
That
interested
you can
to
be that much far from a particular
correct.
deviation from mean.
Correct. Basically, whenever you are interested to find, let's say, can you say something, let's say, more precise about, no, about my X bar and view? Can okay in those scenarios. Basically, you want to calculate how close, okay, X bar and mu are, or else let's say, okay. So for this, what you will you want to do basically, you want to, let's say I'm saying I want to put a number for this, okay, Means to find that precision, right? I'm interested to put a number for this scenario. So in those cases, weak of large number help us. Basically, you want to find how will you quantify how close your x bar and mu are. Basically, where x bar is greater than mu plus delta, x bar is less than mu minus delta, or modulus of x bar minus mu is greater than some delta or not. Okay, so if you go with this part, what it says, let me write. Suppose I'm saying x1, x2, xn. This is IID with any x. Okay, and expectation of x is mu, and variance of x is sigma square. So this means what? Since each xi is IID, I will say expectation of each xi is also mu, and variance of each xi is also sigma square. Then we have seen, if I want to define sample mean, so how will you define x1 plus x2 plus so on, xn divided by n. So what will be the expectation of x bar? We have seen, tell me, this is mu, and variance of x bar will be
Rho square by n.
sigma square by n. Okay. So what weak law of large number says, probability that modulus of absolute difference between x bar minus mu is greater than some quantity, some small quantity. This will be less or equal to sigma square by n delta square, and this will converge to 0, this part, as n tending to infinity, means when n is large. So basically, this is nothing but this is a result of Chebyshev inequality. So what you can observe from here also, so probability that x bar minus mu is what? Expectation of x bar, right? Greater than delta, less or equal to what you can see from here. This sigma square by n is what? Variance of x bar divided by delta square. All right? Am I correct? Yeah?
Yes, sir.
Okay. Now,
Sir, actually, I have some doubts at the concept level.
yeah.
So here, the last step, x bar minus e of x bar. So is it wrong if we say x bar minus e of x? Because
Since your exercise are IID, you see, mathematically you can say it's correct because E of x is same as E of x bar. Okay, but technically you can. I will explain you what is the reason. So I'm writing this means this is my random variable, one random variable, and here I'm talking about expectation of that random variable. Basically, okay, I'm interested to find the absolute difference between those two random variables. Okay, mathematically it's correct because anyway, if you are writing x bar minus expectation of x, this is correct because expectation of x and expectation of x bar both are mu. Okay, but idea behind is probability that x, let's say I have any x, expectation of x difference, the absolute difference between these two greater than delta or epsilon. It's variance of x divided by epsilon square. So this is x, expectation of x, variance of x, and this part. So that's the idea. Okay.
okay.
Okay. Now, so our question was we have to calculate the value of n such that this quantity. Okay. So here x by n means okay. First of all, x follows gamma alpha comma beta. That means alpha by mean will be alpha by beta and variance will be alpha by beta square. Okay. Now, if you see, let's say I have n IID random variable. Okay. What is the given to us? X follows gamma n comma 1. This is the information given to us. I mean alpha by beta and alpha and beta, alpha is n and beta is 1, right? Yes or no? What we have to find, we have to calculate modulus of x by n minus 1 greater than 0.01. This should be less than 0.0. So by using the weak law of large numbers, so what x can represent? Anyone? Any idea? What should be your x? Can you relate? This is a weak law of large number, and we have been given absolute difference between x by n minus 1. What is x here? Any thought?
Right. So, uh, 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 uh,
X is a random variable, simply one value.
Okay, first of all, what it represents? This is X bar, right? Minus mu. Yes or no?
X bar represent average value and mu represent expected value.
That's okay. That's the same thing. So what I'm saying, what is the X here? Can I write
Uh,
summation of
sum
X?
of x.
Correct. That was my question. So can I write X as here x1 plus x2 plus so on? How many X are? I'm talking, we are talking xn. Can I write here or not? Yes, no?
Yes, sir. Yes, sir.
I can write. Correct or not?
Yes.
Everyone is getting this point or no?
So essentially, if we replace x with x1 plus x2 plus xn,
Hmm.
because it is already being divided by n, which is the sample size n,
Correct.
you get the x bar,
X bar.
sample mean.
Okay. So let me try to explain. So we'll try to do in two approaches, both two approaches. First of all, can I write this x as x1 plus x2 plus xn? I will explain you. So something we have seen, summation of n gamma, we have seen it will be, let's say I told you, right, xi is gamma alpha comma beta, then summation of gamma xi will follow gamma n alpha comma beta, right? This is something, this property we have seen, right? Just go with the property for now. All
Okay.
right. So if this is the case, so can I write n comma 1? So that means what? If you'll apply here, can I say here each xi is what? 1 and variance of each xi is 1? Yes? No? Okay. Forget about this part.
Yes, sir.
I think you are not getting here. Okay. If I'm saying, let's say I'm saying each xi is, gamma, can I write 1 comma 1 now? Is this okay? Then
Why are we writing 1 1?
I'm talking about each xi. I'm going to represent x as a x1 plus x2 plus xn. I'm trying to relate with this part. One concept is if each xi, independent xi is gamma, alpha, comma beta, then summation of each xi will be gamma n alpha, comma beta. So here I'm saying x is nothing but x1 plus x2 plus xn. Okay. Then can I
Okay.
say xi is gamma 1 comma 1? Then this xi, that is which is x, will follow gamma n alpha. So alpha is 1 and this is n comma 1. I'm talking about this part only. Now, are you able to relate or not?
Yes.
Yes.
Can I
Yes,
say
sir.
this part, right? Right? Okay, one more thing. If you see what I have told here. So this will be x bar minus expectation of x bar and variance of x bar. Okay, the thing is we need variance of x bar. That's why we are doing like this. Okay. Now tell me if this is the case. So what is the mean of here? What is the expectation of x here?
N by 1, n,
Alpha by beta.
n.
That is n by 1
Yeah.
and anything wrong? Okay, correct, fine. Okay, one more thing we can do directly also. So what is the variance of x?
And
N,
N.
right? Now tell me what will be the expectation of x by n? N by n?
1.
1. Variance of x by n?
1 by n.
Is also 1.
1 by n.
Oh, yeah, 1 by n. Correct.
Correct.
Yeah, n by,
This
1
will
by
be
n.
basically n square
N
into
square.
n. So it's 1 by n. Okay. Basically, you can apply that concept. If this is the xi by n, then that will be n mu comma sigma square by n. Okay. So sigma square is anyway it's 1 by. Okay. Now, okay, okay. Let me start from the fresh. Okay. Let me start from the fresh. So what is the information given us? X follows gamma n comma 1, and we have to find n such that probability that modulus of x by n minus 1 greater than 0.01 less than 0.01. So by using the weak law of large number, probability that mod of x bar minus mu greater than some delta should be less or equal to sigma square by n delta square, right? So basically, what we have to map, so this is x bar, mu is expectation of x bar, all right, greater than delta less or equal to, what is this, sigma square by n, variance of x bar divided by delta square, right? Correct? So far so good. So basically, we have to see this x by n, one of the random variable. One should be expectation of this random variable, and here we have to calculate the variance of that random variable. Yes or no? So what is the expectation of x? If x is gamma n comma 1, so alpha by beta n by 1, which is n. So this means expectation of x by n is nothing but n by n, which is 1. Now variance of x is n by 1 square, alpha by beta square, which is again n. So that means variance of x by n is 1 upon n square into variance of x. So n by n square, which is n.
1 by n.
Oh, sorry, yeah, correct. So it's a 1 by n. Till now it's clear. So what we have to do, basically, we can see whatever the random variable is there, this is the expectation of that random variable, and here should be variance of that random variable. Yes or no?
Yes, sir.
So by using the vehicle of large number, so this should be x by n minus expectation of x by n is, let me write like this, minus expectation of x by n greater than some delta less or equal to variance of x by n delta square. Is this clear? Yes or no?
Yeah.
Now,
Yes.
x by n, what is the expectation of x by n? It's a 1 only. Greater than delta and less or equal to, what is variance of x by n? Which is 1 by n delta square. So, is this clear so far?
Yeah.
Now, in the question, it has been given that probability that mod of x minus n and x by n minus 1 greater than 0.01, right?
Correct.
This should be less or equal to 1 upon n into 0.01 square.
Whole square.
Correct? Is this clear now?
Correct.
But in the question, it has given the less than 0.01. By using this, we have to calculate the value of n. So one more thing we have been given in the question, probability that modulus of x by n minus 1 greater than 0.01. This is given as 0.01. But ideally, it should be the above part, this part, right?
Yeah.
By using this, can I write 1 upon n 0.01 square? This should be less than or greater than less than 0.01 or not? Because this is
Yes.
given to us, right? Can I write like this from this, let's say,
Yes.
star and double star?
Yes, sir.
Yes
Sir,
or no?
sir, is it less than or is it equal to, sir? Because
No. Why not equal to? I would tell you. So thing is, this is upper bound is given to you, right? This is already says this probability for this upper bound is this. This means whatever the quantity is there, this will be less than with this.
okay.
Okay. So now you have to basically calculate the value of n from here. I mean, this will give you some. So what it will be? It will become basically 1 upon
I think it is 10.
cube,
It's 1 million.
right?
Yeah.
Is this correct?
Yeah, correct.
Right.
Yeah.
So basically,
N is 1 million.
n is greater than
1 million.
so it's, I can write 0.01 as a 1 by
100.
100 cube, right? So 100 cube
100
means,
to 100. 1 million.
yeah, 10 raised power 6, correct?
Yes.
So basically your n should be greater than 10 raised power 6. Is this clear to all of you?
Yes, sir.
Okay.
But yeah, doing it on our own is finding it challenging to connect all those dots. But yeah.
No,
But
is this clear, right? So let's try
Yeah.
to do, yeah.
Yeah.
So let's try to do the next question. It's based on the same thing, but here you have to find the value of n by using the, basically you have to, what you have to do, you have to go with the central limit theorem. Okay, so if you want to use the central limit theorem, that means what you have to do, you have to convert your random variable into standard normal variable. Okay, so what is your variable? Go with that. Yeah. Clear? Question is clear to all of you, right? What you have to do.
Yes, sir.
So let me give you 3 minutes and feel free to ask for extra time. It seems Abhijit is your savior, right?
Yeah, actually, I see him. I think he's following very closely and he's able to answer most of the things. So I thought, you
Yeah,
know,
no problem. No problem. That's a good thing to connect with.
yeah, thank you, sir.
So here you have to think what is the key thing, right? So if you want to apply the central limit theorem, so what you have to do, random variable minus expectation of random variable divided by variance of that, sorry, standard deviation of that random variable. So here my random variable is x by n. So you have to think what is expectation of that random variable and divide by variance of that sorry, standard deviation of that random. Okay, and apply the. And if you need extra time limit, do let me know. I will increase. Uh, Anyone extra time limit?
Yes, sir.
We give you 3 minutes. Wait, do you want extra time limit or should we proceed?
Proceed.
Okay, so you can see by week law of large number, it was n should be minimum 10 raised power 6, right? Let's try to do with the central limit theorem. So if you see what is the case, probability that modulus of x by n minus 1 greater than 0.01 and it should be less than 0.01. So that's something we have been given. So if I want to use the central limit theorem, then what should be my step? So to use the central limit theorem, I have to convert my random variable to standard normal random variable, right?
Yeah.
So what is, and we have seen what is the expectation of x by n. Suppose this is as your random variable, let's say y. Y is given as a x by n. So what was the expectation of x by n? We have seen,
One.
right? It was 1. And variance of x by n, 1 by n, right? Correct or not? So this was
Yeah.
1. And variance of x by n was
1
1 by n. That is something we have seen already. So if I want to convert my random variable into standard normal variable, then what I will do? I will do x by n basically. So let's say x by n is y. So I will do y minus expectation of y divided by standard deviation of y. All right. Yes or no?
Yes, sir.
So what is my y? Y is x by n minus expectation of y is 1.
Yes, sir.
So this is 1. What is the standard deviation of y?
1 by n square root.
1 upon square root of n, right?
Yes, sir.
Is this okay?
Yes,
So
sir.
if you see here in this part, if you focus a bit, so this part is there and expectation is already given to us, right? Subtraction
Yes.
with expectation. Then to convert into standard normal variable, what I have to do? I have to divide with only 1 upon root n. Yes or no? You can see
Yes.
this part is
Yes.
already given, right? If let me highlight with some other color, you can see this part is already given to here, right? And I want to convert this part into standard normal variable, then what I will do, I will divide with only 1 upon square root of n. The same thing I will do on the right hand side of the so inequality. So you can see I'm not subtracting the mean on both sides because mean was already subtracted. Is this clear?
Yes, sir.
Why we didn't do 0.01 minus 1? Clear to all of you, right?
Yes, sir.
So now it will be probability and this will be z, right? Modulus
Yeah,
of
it will be Z.
greater than 0.01 square root n.
Yes, sir.
So far so good. Now
Yes.
we have seen if this is the z greater than this part by using the normal probability plot. If you see this is suppose normal curve, this is at 0 and this suppose this say I'm minus a, suppose this I'm saying a. So due to symmetricity, these two will be equal, means probability that z less than minus a, this is same as probability z greater than a. Yes or no? That is the property of
Yes, sir.
normal.
Correct. That's correct.
Correct. Okay. So if I have probability this part z greater than a, what else I can write? I can write this as a
1
probability
minus
z greater than a plus probability z less than minus a or not.
Yes, sir.
Correct. So if
Yes,
this
sir.
is the case and we know this z less than minus a will be same as z greater than a. So can I write z greater than a plus probability that z greater than a?
Yes, sir.
And this is the case, can I write 2 times of probability
Twice
z
of.
greater than a, right?
Yes, sir.
Is this clear to everyone?
Yes, sir.
So if you see instead of a, what we have, let's say 0.01 square root of n, correct? Yes or no? In the
Yes.
place of a, what we have, 0.01 times square root of n. So what I can write 2 times probability z greater than 0.01 square root of n less than 0.01. Is this clear to all of you?
Yes, sir.
Everyone is getting this part, right? How we are moving.
Yes, sir.
So what else? What is the next step? Probability z greater than 0.01 square root of n less than 0.01 divided by 2.
Yes, sir.
So what is the value of 0.01 divided by 2?
0.005.
0.005, right? So
Yes, sir.
right hand side will be 0.005. So this will be probability z greater than 0.01 square root of n less than 0.005. But one more thing, if I want to use the fz value, I need to convert. I can write this will be implies. Okay, so I should write probability z less than or equal to 0.01 square root of n,
Yes, sir.
right? Because this is greater than sign, right? I want, if I need fz value, I need to convert in less than or equal to. So if this is the case, 1 minus, I can write fz of 0.01 square root of n less than 0.005 or 005, right?
Yes, sir.
Now can I write 1 minus 0.005 less than fz of 0.01 square root of n?
Yes, sir. We can write it.
That means what? Can I say fz of 0.01 square root of n, this is greater than, this will be 0.995,
0.995.
correct? So
Yes, sir.
what is the value given to us? What is 0.995? fz of 2.58.
2.58. Yes,
Okay.
sir.
So can I say fz of 0.01 square root of n, this is fz of 2.58.
Yes, sir.
Everyone is getting this part? And if
Yes,
this
sir.
is the case, can I say 0.01
Yes.
square root of n is greater
Is equal
than
to 2.58.
2.58,
Yes.
right? So from here, I can say square root of n is greater than 2.58 divided by 0.
0.1.
Okay. So basically, this will become nothing but
258.
258.
258.
So it will be square root of n greater than 258. So n will be greater than 258 square,
Square. Yes, sir.
and n will be greater than 258 square, whatever it's. Sorry?
Greater than or equal to 258 square plus 1.
Why plus 1?
It should be greater than or equal to, no, sir? No. We are getting answer n as n greater than 258 square,
Mm-hmm.
but I thought it should be greater than or equals to. So,
I think it's continuous, right? I think we can go with it. But anyway, if you see in the question, it's given less than only. Yeah.
okay, okay.
So basically, what is the 258 square? It's some, let me calculate it, 66564, right? Is this correct? So basically, question should be like this actually. Find the minimum value of n. Yes or no?
Yeah.
Okay. So that should be,
Correct.
I think 565. 565. So, yeah. So you can relate with this now, the difference between, by using the central limit theorem and the weak law of large number. Okay. In weak law of large number, what was the value of n? It should be greater than 10 raised to power 6.
10 raised power 6.
Okay, let's come to the next question. Question number 5. We have to apply the concept, whatever the things we have learned so far. Okay, so I would like to give you some 3 minutes. Okay, please try to solve this question, okay? Because I think we have discussed some questions based on this. Okay, it will be great if you are doing. Okay, so anyone, do you need extra time limit or should we proceed?
Little more.
One more, 1 minute?
2 minutes.
One more minute, right? Okay, anyone? Extra time limit or should we proceed? Okay, so 2, A, B, and C. Okay, let's try to understand the problem. So question says, suppose the speed of vehicles on a particular road are normally distributed with mean 25 and where standard deviation is given to as 3. Okay. Uh, Find the probability that mean speed, that is x bar, of 30 randomly selected vehicles is between 24 and 27. Okay. So I can say x denotes the speed of vehicles, right, on a particular road.
Yeah.
Correct. So x denotes the speed of vehicle. So what is the expectation of x is given to us? 25, and variance of x 3 square, that
9.
is 9, right? And n is given to us as 30. So that means what? If this is the case, can I say what if? Okay, first of all, they have selected 30 samples, right? So x1, x2, x30. These all are IID from x. Basically, this is normal from 25, 9. Yes, no.
Yes.
If this is the case, we have seen x1, x2, xn are IID normal mu comma sigma square. Then what is the distribution of x bar? This will be again normal
25,
mu
9 by
comma
30.
sigma square by n. So 9 divided by 30. Yes or no? Is this clear to all of you?
Uh, I didn't know that before, sir. Yeah.
Okay. So what we have seen in case of x bar, this is something we have seen, right? This part.
Yeah. X bar
If
is
x1,
normal.
x2, xn are IIDX with some mean mu variance sigma square, then suppose my S is x bar, then x bar is normal with mean mu and variance sigma square by n.
Okay.
Right? That's what I'm saying.
Yeah.
Okay, so okay, one more thing you can simply cross check. So x bar is what? X1 plus x2 plus x 30
by
divided by 30. So
Correct.
what will be the expectation of x bar? 1 upon 30 into expectation of each x size.
Correct.
All are ID, so it will be
N into mu.
correct. 25 times 30 divided by 30. 30
Yes.
will get cancelled, which is 25, which is mu. And
Correct.
variance of x bar will be variance of x1 plus x30 divided by 30. So it
Yeah.
will be 1 upon n square, that is 30 square, and variance of each xi. What is
N
that? Is
N
9
into
plus, correct. So this will be 30
into 9 by
9
30
divided by 30
square.
square, so which is nothing but 9 by 30, which
Correct.
is I have written, right? Basically your x bar will follow normal with mean mu and sigma square by n. Okay, where mu is nothing but expectation of each xi and sigma square is variance of each xi, right? So from here we got x bar follows normal 25 comma 9 by 30. This correct?
Correct.
Now,
Correct.
what is the main question? Main question is the sample mean. We have to find the probability that the sample mean x bar of 30 randomly selected vehicles is between 24 and 27. So that means what? We have to calculate probability that this x bar is nothing but between 24 and 27.
27. Correct.
Now I can use the what I have to do by using central limit theorem. I have to convert into the standard normal variable. And to convert into standard normal variable, what is the criteria? I have to do random variable minus expectation of that random variable divided by standard deviation of that random variable, right? This x can be anything, right? Y or x bar or anything, yes or no?
Yeah.
So what can I write? Can I write 24? Okay, if how will you convert this as a standard normal variable? Can I say x bar minus 25 divided by square root of 9 by 30 will follow normal 0 comma 1 or not?
Correct.
Is this clear to all of you?
Yes,
So
sir.
what I have to do? 24 minus 25, then that I have to do on both sides, right? Divide by 3 square root of 30, 9 I can take outside, less than x bar minus 25 divided by 3 square root of 30 less than 27 minus 25 divided by 3 square root of 30. Is this
3
clear?
divided by square root.
Sorry?
3 divided by square root.
Yeah.
Oh, yeah, correct. Sorry, sir. Yeah, so it will be 3 divided by square root of 30. Correct?
Yeah.
Now, so if you see, this will become
And now
minus 1
Yeah.
and this will be z
Z.
and this will be 2 divided by 3 divided by square root of 30. Correct? So now what we will get from here? So it will be probability that minus square root of 30 divided by 3 less than z less than 2 times square root of 30 divided by 3. Correct? Basically, we have to calculate this value. You can calculate this value minus what is the coming? What is the value for this?
1.82.
1.82 and this
3.64.
64. Okay. And something we have seen, if probability A less than x less than b, x is continuous or continuous, then there will not be any impact for inequality. So what I equal sign, equality sign. So this will be, we know fz of b minus fz of a.
Yeah.
So I can write here fz of 3.64 minus fz of minus 1.82. So there will be option. Okay, I think 3.64 something is coming.
Yeah, something.
Okay. Yeah, so that, I think this is
3.65 is very close, sir. Yeah.
Yeah. So this will be 3.65 then. Okay. So first option is correct. Okay. Do not get confused with second one. Okay. Clear this part?
Yeah.
So first is correct. So the very last question. This is last question. We have to find the fourth moment of the normal 0, 9 distribution. Okay. You have session at 8.
Yes, sir.
Yes, sir.
Okay. It will
Yes,
take
sir.
very few minutes.
Math
It
and
will take,
Python system.
okay, it will take very few minutes. And after that, though someone asks the questions from activity. Okay, if you want, you can stay and we can discuss. Or else, do you want to try this, or should I discuss the solution directly?
No, this is formula based. This is something 3 sigma to the power 4.
What is lambda in this case?
That's what you to identify.
Yeah, mu I have, rho square I have, mu equal to 0, rho square equal to 9, lambda.
Actually, if you want to find the any moment, okay, let's say second moment, then it should be the coefficient of, let's say, kth moment, okay? Then it will be coefficient of lambda raised power k divided by k factorial in mx lambda.
Fourth moment is 243.
243. Let's see. Okay, let me do it, okay? Because you said so. What is fourth moment of normal 0,9 distribution? So let me explain you the concept basically. If I'm talking about MGF of any random variable, then mx lambda is given as nothing but expectation of e raised power lambda x, right? And what is the extension of e raised power x? It's 1 plus x square by 2 factorial plus x cube divided by 3 factorial and so on, right?
Yeah.
So by using this info, I can write expectation of e raised power x instead of x, I have lambda x. So 1 plus lambda x plus lambda square x square divided by 2 factorial plus lambda cube x cube divided by 3 factorial and so on. Correct?
Yeah.
Now what I can write, if you take expectation inside the bracket, so I can write 1 plus lambda times expectation of x.
Correct.
Plus lambda square divided by 2 factorial into expectation of x square plus lambda cube divided by 3 factorial into expectation of x or cube and so on.
Correct.
So in general, what in moment generative function, basically, if I want to find the kth moment, okay, so kth moment, that is nothing but expectation of x raised power k. This is nothing but coefficient of lambda raised power k divided by k factorial. This is in general. That means if I will talk about the first moment, the first moment will be expectation of x, which is nothing but coefficient of lambda raised power 1 divided by 1 factorial, that is coefficient of lambda, which is expectation of x directly, right? You can see. Yes or no? If I talk about second moment, then that is nothing but expectation of x square. What is this? This is coefficient of lambda raised power 2 divided by 2 factorial or not? Expectation of x square. This is coefficient of this quantity.
Yes.
This is third moment. Okay, this is first moment. This is second moment. This is third moment. So you can see, if I talk about in general, so kth moment is nothing but expectation of x raised power k, which is coefficient of lambda raised power k divided by k factorial. All right.
Yeah.
Now, question was, we have to calculate the fourth moment of normal 0,9. So fourth moment means what? I need to calculate the expectation of x raised power 4.
Yeah.
Which should be coefficient of lambda raised power 4 divided by 4 factorial. Yes or no? Coefficient of this in what? In mx lambda of this random variable, a normal distribution. Yes or no? So if I'm saying, okay, is this the relation is correct? Are you getting? Yes or no?
Yes, sir.
So x follows normal 0, sigma square. Then what is the mx lambda? It's something you can recall from the lectures or told if someone is
So sigma square.
Sorry?
Sigma square and e to the power of
Lambda square
into sigma square by 2. Yeah.
I think if you can recall the statement of the sir told, if someone is asking in the midnight, you should be able to answer for this question.
Correct. Yeah.
Okay. So what is the sigma square is 9 here, right? Okay. Yes or no? So 9 is there, right? So let's say, can I write mx lambda by using this information? E raised power lambda square 3 square divided by 2.
Mm-hmm.
Yes or no?
Yes.
Now, by if you see, so this part, we know what is the expansion of e raised to power x, 1 plus x square by 2 factor and so on. So can I write this as the 1 plus x? So instead of x, lambda square 3 square divided by 2 plus x square. That means lambda raised to power 4, 3 raised to power 4 divided by 4
2 square.
to 2 factorial.
Yeah, correct.
Correct? And so on, right? Now, if you see, so what we got 1 plus lambda square 3 square by 2 and lambda raised to power 4 divided by, and what we have to calculate?
We need to
Fourth
get
moment, that is coefficient of lambda raised to power 4 divided by 4 factorial, right? But if you see in the denominator part, we have 4 into 2 factorial. So to find the 4 factorial, what can I do? Can I multiply with 3 and divide by 3?
yeah,
Yes or no?
correct.
Then denominator uh, will be
Will be lambda to power of 4 by
4
factor.
divided by 4 factorial into 3 raised to power 5.
Yeah, correct.
Is this
Correct.
okay to all of you? And what is the fourth moment? So fourth moment basically
Is the
is
lambda
nothing but coefficient of lambda is for 4 divided by 4 factor, which is 3 raised to power 5, which is 240.
3?
Okay,
Yeah,
clear to all of you?
yeah, perfect, sir.
Sir, can you just scroll up the page little bit?
Okay,
The above page.
okay. This one?
Yes, sir. Just this one. Yes, sir. Thank you, sir. Thank you.
So I think okay, that's all from this slide. So I think someone has doubt. I think I can recall Bismith, right? I don't know. Yeah, Bimles. You had doubt from activity 8.2, right?
No, I think now I can do that.
You can do. Or if you want to try, we can try some, let's say third and fourth question, which seems a bit.
Yes.
Or everyone were able to do.
No, sir, you can try. Yeah, if you have time, you can try that.
Yeah,
No,
I
let
have
us
time.
do all the 4 questions now.
Okay, let me do then first, third, and fourth. Second, you can try on your. Okay.
Yeah, sure.
Okay. So okay. Now, what we will do in this situation, I will write the question and we will go step by step, and you will tell me what should I do. Okay.
Perfect, sir.
Okay. Let's try to see whether you got the idea or not. Okay. So, very first question says the average life of a coffee machine is 5 years with a standard deviation of 1 year. Okay. Assuming that the lives of these machines follow approximately a normal distribution, then find the probability that mean life of a random sample of 16 such machines falls between 4.6 and 5.4 years. So first of all, what are the things given to us?
We got the mu.
Mu as a 5, right?
Yeah,
Okay,
mu is 5.
Okay, let me. So activity 8.2 question 1. So whenever you are reading any question, just write whatever the things is given. So mu is 5, average life. Standard deviation is 1, right?
1. Correct.
Yeah. So assume the life of these machines follow approximately normal distribution. So let's say you can say X follows. X is life of coffee machine. Okay.
Correct.
That is something is given to us. So we have to find the probability that mean life of a random sample of 16 such machines. That means I have given 16 machines.
N equal to 16.
Correct. And this mean life between 4.6 and so basically we have to calculate mean life. Let's say X bar is fall between 4.6 and
5.4.
That is something we have to calculate. First thing, so X is given to us, and we know X1, X2, Xn is IID from let's say normal mu comma sigma square. Then what was the distribution of X bar? Mu comma sigma square by n or not? I mean expectation of X bar will be mu and variance of X bar will be sigma square by n.
Yeah.
That is something we have seen, right?
Correct.
Now, by this case, in this case, it will be X bar will be what? Normal, and it will be mu is 5 comma 1 by 16?
16.
Is this correct? Okay.
Yeah.
Now you will say n is very small actually, but you can see initial distribution is already normal. Okay, then I can convert in standard normal. Okay, is this clear? Now, what we have to do to find this standard normal, what I will do, I have to convert it in standard normal. Then what I will do, I have to subtract the mean and divide by the variance, standard deviation. So 4.6 minus, what is the mean of x bar? Basically, what we have to do,
5.
x bar minus expectation of x bar divide by standard deviation of x bar, only then it will be z, right?
Correct.
What is the expectation of x bar? 5.
5.
Divide by standard deviation of z bar,
Yes.
1 by 4.
Yeah, correct.
Because this is the variance, right?
That's correct. Correct.
And this will become 5.4
0.4
minus 5 divided by 1 by 4.
By 4. Correct.
Correct. Now, if you see this 4.6 minus 5 will be what?
0.4.
0.4.
So it
minus
will be
0.4. Minus 0.4, right?
Correct. Correct. Yeah.
Less than, this will be simply z. And this will be 0.4 divided by 1 by 4.
Yeah.
So if you will calculate, this will give you minus
1.6.
Minus 1.6 less than z less than 1.6, and this will be fz of 1.6 minus fz of minus 1.6.
Correct.
Correct.
Perfect.
Now, if you see fz of 1.6 should be given to us, yeah. So this is 0.9452 is given to us, right? Okay. One more thing, it's 1.6 is given to us. So can you see from here, fz of 1.6 minus, this is what? Probability z less or equal to minus 1.6, right? I want to, because why I'm doing like this, because only positive value is given to us. Okay, I will try to show how to proceed. So if this is the case, if you see the standard normal curve, suppose this is minus 1.6, this is 1.6. So this probability should be same as this part.
Correct.
So can I write this as a probability z greater than 1.6? Yes or no?
1 second, sir.
So this probability z less than minus 1.6 will be same as probability z greater than 1.6 due to symmetricity,
correct,
right?
Correct.
Right. This graph we have to adjust. So it will be, now this is in greater than sign, right? I want to convert in standard normal, then also not z. I can write 1 minus probability z less or equal to 1.6. Yes or no? This part, greater part, like this, just to convert in fz. All right. Minus, yes or no? Are you getting, everyone?
Yes, yes.
Okay. So this will be fz of 1.6 minus 1 plus fz of 1.6. So this will become 2 times fz of 1.6 minus 1. What you will do, just substitute the value of fz, 0.9452 minus 1. Can you calculate this value?
Yeah, it's 0.9.
0.9452. Yeah, so 0.89 something, right? So we can see the answer if you check the answer. So it's coming. Yeah, so 0.89 is answer, right?
Yeah.
Is this clear? Question is clear, approach?
Yes, yes.
Basically, what you have to do, you can see the value of positive values is given to you. So directly you can go with this. So see, if this is the given to you, I'm saying I'm interested to calculate this part. Okay. But can I do 1 minus this part? 1 minus probability that z greater than? Okay, forget about this if you're not getting. This is okay, right? This is steps. And this and this. All right? Yes? No?
Yes, sir. Yes, sir.
Okay. Now let's try to do the third question. So second question I'm not doing because of you can calculate the basically expectation of x. You have to do 4 into point because see, right? You got the idea. We need expectation and variance, right?
Correct.
Let's try to do the question number 3. Question number 3 says an electrical firm manufactures light bulbs that have a length of life that is approximately normally distributed. So this is saying X is the length of life which is normally distributed with mean equal to 600 hours, standard deviation of 50 hours. That means question 2, 3, mean is
600.
600 and sigma is 50. Sigma square will be 50 square. Now, find the probability that random sample of 25 bulbs will have an average life of less than 615 hours. So what is the n? Is 25. So that means each, okay, x represents what? Length of life of bulb, right?
Yeah.
Something. So each xi will represent the life of ith bulb, right? Which is what? Normally distributed with mean this and variance 50 square. That is something given to us. Yes or no?
Yeah.
Now, you will talk about x bar, and this will be normal mu comma sigma square by n.
Yeah.
Right.
Yeah.
So mu is 600 only, and sigma square is 50 square divided by 25.
25.
Okay. Why we are interested to calculate this part and this part? Because in the question it has been given that we have to calculate the mean life of this 25 bulbs should be less than 615. So this x bar should be less than 615. To convert into standard normal variable, I need expectation of this x bar. I need variance of this x. Okay, so you can calculate manually also. Expectation of x bar is nothing but expectation of x1 plus x2 plus x25 divided by 25. Again, numerator part will be 25 times 600 divided by 25. 25 will get cancelled out. Similarly, in case of variance, denominator will be 1 upon 25 square into variance of sum of each 25 random variables. Okay, is this clear?
Yeah.
Are you getting this part, right? So what, okay, tell me what should I do next?
X bar minus 600 by this is 100, so it is
basically
10.
square root of 50.
Yeah.
Okay, let's solve this. So 50
that is
square
10, sir.
Is
It comes
100,
to
yeah,
100.
it's
So
10.
10.
Correct, it's 10. Correct.
Yeah.
Then
10
this will be less than 615 minus
600 by 10.
10.
Should be
This will be z less than
15 by 10, 1.5.
Z less than
1.5.
So fz of 1.5. So 1.5 value is given to us, which is 0.933, right? So 0.93 you can see inside the range. Okay.
Yeah.
One more thing, what if question is given to us? You have to calculate the probability that x bar minus 25 is less than 615. Then how will you proceed?
What is that, sir?
Not 25, 600. How will you proceed? This is given to you.
X bar
Minus 600.
So here
Simply
I already have mu.
standard.
X by x minus mu is already there. So I will simply divide it by sigma.
So right hand side I will do only 10, right?
Correct.
Okay, sometimes what people do is this is given to us, again they are subtracting the 600. So just make sure, okay? Oh, all right. So I think you got the point.
Thanks
I think
for calling that out. Yeah.
Yeah. So next question is a little bit interesting. You have to observe a thing. So question says the number of accidents in a certain city is modeled by a Poisson distribution with an average rate of 9 accidents per day. Okay. So in case of Poisson distribution, we know mean and variances are both are same, right? Means mu is 9, then sigma square is also 9. Basically, lambda is mean and lambda is also variance, right?
Yeah.
Yeah, because it's a Poisson distribution, right? So that means mu and sigma square will be same. Mu is represent the mean and sigma square represent the variance. Okay.
Sir, just one question, sir. Here when we say that for Poisson distribution, mean is lambda and variance is lambda, is it a? Oh, sorry. I thought I'll ask is it applicable only for discrete or continuous? It is obviously continuous. Sorry.
No, Poisson is discrete, right?
Poisson is always discrete.
Poisson is discrete. What is your doubt actually?
No. Actually, when we say for Poisson mean equal to lambda and variance is lambda, is it applicable to only discrete or discrete and continuous for
No.
for any kind of thing? Is what
You are getting confused with mu and sigma square.
No, sir. When I say mu and what
Yeah,
I am
good.
saying is mu. Okay, mean takes the value of sigma.
X is taking values from 0 to infinity, and it's not like 0 and in steps of 1. So it is
Okay.
a discrete.
Let me explain. So if I'm saying X follows Poisson distribution with parameter lambda. First of all, this means X is a discrete. Okay. Because in case of Poisson, we are interested in number of events occurring in a given space or in given a time interval. Okay. This X can take value 0, 1, 2, and so on. Okay. Now, X is Poisson lambda. In case of this, expectation of X is lambda, variance of X is lambda. In general, we are writing expectation as a mu, which is lambda, variance as a lambda. Do not confuse with this mu is always about normal and sigma square is always about normal. Okay? This is just a standard notation for mean and variance.
Okay.
Understood the difference? Yeah?
Yeah.
So if you see in the question, what is this? Poisson random variable with an average rate of 9 accidents per day. Okay? That is my X, whatever the X is represents, X represents the number of accidents, right? Now, is this clear? So suppose that number of accidents on different days are independent. Means let's say n days I'm talking about. Means x1, x2, xn. So can I say xi represents number of accidents on ith day? Right?
Correct.
Now, use the central limit theorem, find the probability that there will be more than 3,300 accidents within a certain year. Assume that 365 days in a year. So question is, we have to find the probability that more than 33. Okay, if there are 365 days in a year, so that means what? I have to calculate x1. Okay, tell me, what should I write? Number of accidents in a year.
Up to x365.
Correct? So xi represents number of accident on ith day. So x1 will represent number of accident on first day, x2 on the second day till x365. Okay, I'm talking about the number of accident in a year. That means I have to combine all these random variable. Yes or no?
Yeah, n mu.
Right. So this is, suppose this is y, and this will be what? Okay, this will be, what is the mean of this y?
This n
mu.
Sir.
That is 365 into 9. And what is the variance of this y? N sigma square.
Sigma square.
See, variance of y. It is mentioned that all these are independent, right? Number of accidents on different.
N sigma square. Correct.
So this will be variance of x1, variance of x2 plus variance of x365.
Correct.
Which is 9 plus 9 and so on, 9, which is 365 into 9 again.
Correct.
So now I have information that my y will follow normal with mean 365 into 9 with variance 365 into 9. Is this clear? So now you can see the expectation of y is this, variance of y is this. So question is, this number of accidents throughout the year will be more than 3,300. That means y will be greater than 3,300.
Correct.
Then my next step should be y minus expectation of y divided by standard deviation of y greater than 3,300 minus expectation of y divided by standard deviation of y. All right. So this will become z greater than 3,300 minus 365 into 9 divided by square root of 365 into 9.
Correct.
So, I mean, just you have to calculate the values and all, it will give you the basic answer.
Yeah.
Okay. So you can see. So okay, to find the, to convert in FZ, what I will do? 1 minus probability z less than or equal to this quantity, let's say A. Okay, this quantity. Then 1 minus fz of this quantity, value of, okay. All right. So you got the idea, right? So sometimes what people make mistake, they simply use this -9 and 9. So do not think like this. Here we are talking about summation of each exercise. So it will be n mu and sigma square. So one thing you can keep in your mind, and we did the solution also, x1, x2 up to xn. These are IIDs with some x, then expectation of x mu and variance of x sigma square. These are some values. Then if I will say s as a x1 plus x2 plus so on xn, this will be normal mu n mu comma n sigma square if n is large. Okay, I'm talking about central limit theorem. Okay, or else if you talk about in general, let's say what will be the expectation of s n mu and variance of s n sigma square, right, in general. And what will be s divided by n means x bar x1 plus xn divided by n. It will be expectation of Sn by n will be mu and variance of s by n will be sigma square by n. Yes or no? Clear? Yeah. Okay. So
Thank
that's
you.
all for today's session. I hope you got the idea how to proceed with the questions related to central limit theorem. Okay. That is
Week
okay.
9 GA can be postponed after this year.
No, Bimles. Unfortunately, we can't extend the due dates of any because it's already mentioned in the grading document. Because of they are to
Unnecessarily will have to go through week 9 before
no,
this.
it's not unnecessarily. I will tell you the reason. If you'll wait till 1st December, okay, then 22nd December is your end-term exam. Within those 20 days, you have to cover all 4 weeks, 9 to 12, and we have to conduct every session for every week along with the revision session. And as well as team has to
Okay.
calculate the
If you want, you can
eligibility
stop
for.
recording.
Sorry?
If you want, you can stop recording.
Yeah, it's fine. It's fine. Okay. So
That
that's
makes
all. Actually, that's technical things we are done. Okay. So let me stop the recording.
Thank you, Sharma ji.
Yeah. Thanks. I hope everyone got the part.
Thank you. Thanks a lot.
Yeah. So that's what we can't extend the due dates. Okay. So I think it's a normal.